time, we will complete it today. Otherwise, we'll do the first 6. Okay. All right. So again, quick recap. List is represented by box brackets, right? And can it have duplicate elements?
No.
Yes, ma'am. It can have duplicate elements.
Yeah, it can have
It
duplicate.
can have duplicate elements. Okay. And what about dictionary? Dictionary is represented by braces.
Braces, curly braces.
And duplicates are allowed or not?
Not allowed.
In the key.
Duplicate keys are not allowed, but duplicate values can be.
Keys are unique, but values can be duplicate, right? And there can be dictionaries within dictionaries, right? So like each key value pair can also be another dictionary.
Another dictionary.
Okay, so the concept of nested dictionaries is going to be used in this week 9. Okay, to implement the graph. Okay, so everyone is familiar with the matrix structure, right? How it looks. Like there can be a matrix like this.
Yes, ma'am.
So this type of matrix, it is what type of a matrix? Can anyone tell me? This is a square matrix, right? And what are the dimensions of the matrix?
3 cross
3 into 3.
10 times.
3 cross 3.
This is 3 times.
So this is your row and your columns, right? So
Yes, ma'am.
Basic convention is that in a matrix, each element is represented by this. Okay, so if this is matrix M, so each element, say this one, okay, this will be represented by
M1 and 1.
some Mij. Okay, so usually I and J are representing what? Indices of your rows and columns. So rows and columns, conventionally we start from 0. Okay, so this is row 0, row 1, row 2. This is column 0, column 1, column 2. So if I say what is the value present at row 1, column 2, what will be the answer in this one?
8.
2, ma'am.
I said, see, row 1 and column 2.
5. 2,
Ma'am, 5,
values 2.
3. 2, ma'am. 6.
It will be 2.
6. 5.
See,
5.
not so
Five.
many different
It is
answers.
6.
Okay. It's one correct answer.
Row 1, column
6
2,
is
ma'am,
the
3.
answer. This is row.
6, ma'am, 6.
Okay, and this is column.
Oh,
So this is the row number 1 and this is column number 2. So you go from here and then come here, this element. Okay. So again,
yes, ma'am.
one more. So what is column? Okay, let's take. What is row 2, column 0?
7.
4.
7, ma'am.
7 and 7.
Look, don't
7.
see what you're getting confused in is the index. Okay, so yeah, this is the first row, this is the second row, but what are the indices? First row is represented by 0 index, right? Second row is represented by 1 index. So when I say M20, so this is the index of the row. So row 0, row 1, row 2. So this one, and column is starting from 0 index also. So this
Yes, ma'am.
column
7.
and this row, this one, right? 7. So this is your basic matrix structure. Okay. Now, how are we going to implement this using pseudocode? See, for every first of all, this whole matrix will be represented using dictionaries. Okay. So there will be an outer dictionary and a nested dictionary. Now there will be a number of different nested dictionaries depending on what is the dimension of your matrix. Okay. So if I have this 3 cross 3 matrix and I want to represent this using my pseudocode. Okay. So what I will do, the outer matrix will be run for the rows. Okay. You can do it anyway. You can take the outer matrix to represent the columns, or you can take it to represent the rows, and just accordingly, you have to change the nested matrix. Okay. So if the outer matrix is representing your rows, then for every row, okay, every row index is a key for that matrix, for that outer matrix. Okay. Now for every single row, there are going to be how many columns? As many columns as are there. Like if you have an M cross N dictionary. So M is the number of rows, M cross N matrix. M is the number of rows and N is the number of columns. Okay. So for every row, there are going to be N number of columns.
Yes, ma'am.
So if I say row 0, then row 0 will have a nested dictionary associated with it, where again, within that nested dictionary, each of the keys will represent each of the columns. You can do it in the reverse way too. If the outer matrix is representing the columns, then for every column, the inner nested dictionary, like for column 0, if I start with, the inner dictionary will have three distinct keys for row 0, row 1, row 2. Okay, again for the outer dictionary, the next key will be 1, and inner dictionary will have again three distinct keys for row 0, row 1, row 2. So like this, using that nested dictionary concept, we are going to implement the graph. Okay. So again, here's a little recollection. So a list keeps a sequence of values. No random access is possible, right? If a list has 10 elements, I want to access the 8th element, I have to start from 0th element and move, traverse in linear order. Okay. And for a value at position I, start at the beginning and scan I minus 1 elements. Why? Because again, list index also starts from 0. Okay. Whenever we are talking about index, it is always better to start from 0. So if I say that my list has n elements, then what are the indices going to be? 0 to n minus 1.
Yes.
Okay. So this is list. Then what is dictionary? It stores key value pairs, like you said. Supports random access. Using any key, I can reach any value that I want. You can just pick out the unique key. And keys can be arbitrary values. Okay, and values can be duplicates or anything you want. Now, the values can also be in the form of lists or in the form of nested dictionaries, like I said. Now, what is a matrix? A matrix is nothing but a two-dimensional table. Okay. It can be any, you can think of any random table that you have seen so far. Like any of the data sets also, we can pick and form a table out of it. Any two-dimensional table, we can call it as a matrix. Why two-dimensional? Because it has rows and columns, right? Now, rows represent a dimension, columns represent another dimension. So two-dimensional matrices have just rows and columns. So if I want to, in general, say what is the matrix representation of a table with m rows and n columns, then we will write it is an m cross n matrix. And each element that we want to access in a matrix, how are we going to access it? So let's say my matrix name is M, or just a matrix, let's say, and it has m rows, n columns. Okay, now I want to get some random element from that matrix. Like, let's say I want the element that is in the ith row and the jth column. Then I will write matrix, then first the row, then the column. Okay, this is how we will represent. So this is also giving you random access, because just by using those indices, you can reach any element you want. By convention, rows and columns are, like I said, all indexes are starting from 0. Okay. Now, this can have a little bit of confusion among students, because there are activity questions on this also. See,
so
if I say
just
that
as a question, because these both are will be, like you told me that keys can be horizontal, like in the columns also as well as in rows, right? So then how
yes,
will you be defining that? How different?
can you repeat the question once?
Because like there would be keys in the rows, right? With respect to columns, right? So if I need to call, suppose.
See, the convention that we are following is that the first box bracket, this is containing the row number. Okay, and this is the column number. What I said earlier is that when we are going to learn the pseudocode representation of a matrix, then you can take the outer dictionary as rows or as columns. That's up to you. Okay, but representation will be like this.
So
Come again?
you want to say that for these both are nested dictionaries, right? J would be I
Right,
to
both
J,
are
right?
nested.
I
Yes.
to J. It's like be I to J.
So this is
I
ith
would
row,
be
and
having,
in that ith row, you have to find the jth column.
So ith row and J column. Okay.
Yeah. Like in this matrix that I drew here, if I say Mij and I am trying to represent, let's say, row 2 and column 1. Okay. So this is my ith column is now my ith row is now my second, or a row with index 2. That is this row. Now in this row only, I will search for column with index 1. That is this column. So I'll get this value. This row, this column. Clear?
Okay.
Okay. Now see, okay, this one I was saying. in the activity also there is one such question, that if I say that my matrix is a 4x4 matrix, okay, it's a 4x4 matrix, so I can say it is a square matrix. Square matrix is what? When the number of rows and number of columns are same. Okay.
Yeah, equal.
So in a 4x4 matrix, if I say what is the range of I, that is what values can I take? So I can take values from 0 to, if I have 4x4, then 0 to 3. So 0,
Three.
1, 2, 3. These are going to be the indices of both rows and columns, right? So how can I write that in terms of just general notation? That if I have m rows and n columns in my matrix, then I can range from 0 to m minus 1. And this is going to be what? Greater than equal to 0, because it has to include 0, and again less than equal to m minus 1. Now some people they forget to put the equal to sign in this part. Okay, if you don't put it, then this just becomes 1 less, because you are starting from 0. If 4 is the number of rows I have, okay, and I'm starting from index 0, so it should be 0, 1, 2, 3, right? So 4 minus 1, basically that is 3. So you have to include this 3, right? That's why this equal sign is also very important. It cannot be like you put an equal here but not here, then it will be wrong. If I don't put this equal here, then where will it stop? 0, 1, 2. It won't take 3, right? Because it has to be less than 2. Similarly for columns also, so just be a little careful about this range. Okay. Now this is actually how we implement matrices. So dictionaries support random access that we saw. And in a matrix also, we need random access, right? That is, any element, you just use the row and column index and get that element. So obviously, to implement matrix, we are going to be using dictionaries. So this is a procedure called create matrix. Okay. Now in this procedure, what are the arguments? You have rows and columns. This is yours to give. You are going to specify how many rows and how many columns you want. Okay. It doesn't necessarily have to be a square matrix. It can be anything. Like you can give 2 rows, 3 columns also. That's also fine. So once you put the argument, now what is the procedure doing? Let's see. So first you have an empty dictionary called mat. Okay, this is an empty dictionary. Then I have this value, I have this variable I, which I have assigned the value 0. Okay. Now while I less than rows, that is I less than the number of rows that I have in my dictionary. Why? Because why less than here? Because I need what? 0 to m minus 1, right? Here, if I put an equal to sign, then what will happen? I starts from 0. I want 2 rows and I put an equal sign here. Then it will take actually 3 rows, right? 0, 1, 2. Because it will stop at 2 only. Is this clear?
Yes,
Why
ma'am.
this equal to is not here? It has to be less than the number of rows. Why isn't it erasing? It's not working. I don't know. Anyway, so first I have this while loop where the condition is that this while loop will stop iterating when I becomes greater than the or you can say when I becomes equal to
Equal.
2 in this example. Okay, in this example, say I am trying to create a matrix, a 2 cross 3 matrix where there are 2 rows and 3 columns. So here I will start from 0. For 0, it will do 1 iteration. For again 1, it will do 1 iteration. And then when i's value becomes 2, see I is incremented here actually. So when i's value becomes 2, then 2 less than 2, this condition will become false, right? So it will break out of the loop and return whatever is present in that matrix dictionary. Okay.
Yes, ma'am.
So first, for the first iteration, I is 0. Okay, initialized here. Now, while I less than rows. So for first iteration, I'm writing I is 0. So 0 less than 2. This is true. So I will enter the while block. Now inside while, mat I. Okay, what is this representation? This is a dictionary representation, right? So
Yes, ma'am.
mat I means what? I is what? Key of this matrix dictionary.
Yes,
Correct?
ma'am.
And what is the value I'm assigning to that key? I'm assigning an empty dictionary to that. So this is what nested dictionary. So for every key in this matrix, I will have the value as an empty dictionary, which I'm going to fill up later. Okay. So initially in this procedure, we're using rows as the out dictionary and columns will be used as the nested one. You can do the reverse also. So first, for first iteration, mat I equals to nested, an empty dictionary. So this is basically mat 0. That means this for the 0th row, I am assigning an empty dictionary. Now within this, j is a variable which is again assigned the value 0. Now while j is less than the number of columns, what is the number of columns I'm trying for? 3. So for first iteration, j is first 0. See, j will always be initialized for every outer iteration, j will be initialized to 0. Okay. Now, for first iteration, j is 0, then j less than 3. So 0 less than 3, this is true. So you will enter this. Now, mat ij. Now this is actually forming the matrix, right? The nested dictionary, this is...
Ma'am, your voice is lagging. Is it only for me or for everyone?
No, voice is I think clear.
No, we can
Voice is clear. It's an
That's fine.
error on your side.
No, ma'am, we can
There
clear.
is a network problem.
Okay, just rejoin the meet if you have any issues. Okay.
Okay, ma'am. Okay.
See, now matrix ij. At this point, what is I and what is j?
I is row and J is column.
What are the values of I and j? I'm asking in the first iteration.
0, 0.
0, 0.
0, 0. Okay, good.
0.
So basically, my matrix, since it's a 2 cross 3 matrix, it's not a square one. Okay, it looks sort of like a rectangle more.
Yes.
So 2 rows means index 0, index 1, right? And columns means 3 columns, index 0, index 1, index 2. So first, this matrix 0, 0 is this position, correct? 0th row, 0th column. Now here I'm assigning the value 0. Okay, initially I'm actually filling up my entire matrix with 0 values at every position. So here I put a 0. See this line. Next you have to increment j. Okay, in the inner while, now j is incremented to 1. Now for the next iteration, in the inner while only. Okay.
Inner while, j is
So
incremented.
j is now 1. So 1 less than 3 is again true. So now matrix ij is what? Matrix 0.
0. Matrix.
And
0
1.
and 1.
0.
That is which position? This one.
This position.
Right?
Yes.
Here also I assign the value 0.
Hmm.
First of all, I'm just filling it up with zeros only. Then again, next iteration of inner loop. So now again, j is incremented. J is what now? 2.
Yeah.
So is 2 less than 3? Yes.
Yes.
So I will again enter here and matrix is now 0 and
2.
0 and 2. Very good. So this position. Here also I'm putting a 0. Okay, so the first row I have filled up. Now you have to increment j again. So now j becomes what? 3. Is 3 less than 3?
No,
False.
No, ma'am.
So I will get out of this inner while. Okay. So I will get out of the inner while and I will implement my I value here. Please mute if you don't want to ask anything. So now first row is filled up. I have incremented I after getting out of that inner while. So now my I is what? What is I?
1.
I is now 1. Now I will go for the second iteration of the outer while. Okay. So this is for which row? This row. Now in this row again, once I enter this while block, mat I is again assigned an empty dictionary, right? So this is now mat 1, which is assigned an empty dictionary. Again, j is initialized to 0. Okay. Every time we enter the outer while loop, I will initialize j to 0. Now, while j is less than columns, again columns remains 3 only, but j is again 0. So I will do the same procedure and increment j until j becomes 3, right? And once j becomes 3, this condition will become false and I will increment I again. So in this way, I can fill up this one also, right? With zeros. First one will be what? Matrix 1, 0. That will be assigned 0. Then 1, 1 will be assigned 0. Right? Then 1, 2 will be assigned 0. And then when j becomes 3, you are breaking out of the inner loop and coming here. So what is I now after the incrementation? Here, I is
1.
I was 1.
Yes, 2.
Now I increment it again here. So I is now 2. Now go to the outer while again for the next iteration. but I want 2 rows only. So 2 less than 2, this is now false. That means my matrix is filled, right? So what will I do? I will just execute this return statement and get out of this outer while loop. So it will return this matrix, which is a 2 cross 3 matrix filled with zeros. So creation of matrix, any doubts?
Ma'am, each row is a dictionary.
See, here I am using row as my outer loop, right? That is the outer dictionary. So each row, the index of each row is the key for the outer dictionary. Now for each row, I have an inner dictionary which is containing the column values for that row. Okay, this inner dictionary, see, here I am forming mat I and assigning it an empty dictionary, right? For every new row.
Yes, ma'am.
So this is what for row 0, I have an empty dictionary. For row 1, I have an empty dictionary. So this row 0 empty dictionary is again doing what? In this, I am just assigning the column values, different columns for that row. Okay, if I didn't do this empty dictionary, then this mat ij, I wouldn't be able to represent, right? This j is part of the inner dictionary. This is the key of the inner dictionary. Understood? So your outer dictionary key is rows and inner dictionary key is columns for each row. So basically, in our example, there are going to be 2 keys in the outer dictionary, and for each of those keys, they will have an inner dictionary which again contains 3 keys for each of the columns. Clear?
Yes, ma'am. Ma'am, then we can say that combination of dictionaries is constitutes a matrix.
Yeah. See, main point here is that matrix wants random access, and that can only be given by dictionaries, not lists or anything. So that's why we are using nested dictionary concept to get representation of matrix. Why nested? Because a matrix is what usually we are doing 2-dimensional matrices. So it is a 2-dimensional structure, right? That's why we need nested. Now, just for your understanding, we are not having any other dimensions other than 2-dimensional. But let's say if the dimensions are increased, okay, row, column, and some other dimension p, then how many nestings are going to be there? See, for each row, I will have an empty dictionary for the column. Then again, for each column, you will have an empty dictionary to represent this inner dimension. Anyway, let's not complicate this. Okay, it's just.
We can't
Why am I
visualize
not
in
able
a
to
table.
edit this? One second, some problem is there. Yeah. Anyways, let's not complicate this. So we are basically going to understand M cross N. Okay. So this is outer, this is inner. For every outer iteration, there's going to be how many inner iteration? As many number of columns are there. Correct?
So, ma'am, total mn iteration.
Yes, total M cross N iterations, constituting of both outer and inner. Okay. Like you see, in this example, for every row, how many times was this inner while loop iterating?
3 times.
3 times. And how many rows are there? 2 rows. So 2 cross 3, total number of iterations, right? Any other question from creation?
Ma'am, I have a doubt that if in a question we have to visualize the matrix as a dictionary or a matrix.
Think of it as a matrix.
Okay.
Yeah.
I have a doubt here.
have one question.
With regard to the random access, because now in the matrix we are going only from the 0, comma 0, then we are moving forward as 0, comma 1 and so on in this direction, and then we are moving for the next row. So it is a very sequential way of creating a matrix.
Actually, this is what this is to create the matrix. When we say random access, that is after the matrix is created. Now, if you want to access a particular value from that matrix, so you have your column and row indices.
Yes.
Using that, you can randomly pick out any element. You don't have to go through the entire matrix. That's the point.
Okay. So to directly access that particular column.
Yeah, but when you're filling up the matrix or creating it, then you have to go in the sequential way.
Ma'am, for example, if I initialize I equal to 1 and here, while I am considering I is less than
Then
equal to
nothing,
Rose.
just put an equal to here.
Okay, thank you.
Okay. If I is 1 and if you also want to start j from 1, then just put an equal to here. Okay.
Okay, ma'am.
So if you start from index 1 and you have m rows, so you will have 1 to m. And if you have index 1 and n columns, so 1 to n. Just if you converted this from to start with 0, so 0 to m minus 1 and 0 to n minus 1. Clear?
Yes, thank you.
Can we say it's like a table of keys and each key can have a value in the, like it's a table of keys and then each row or column is a dictionary. So each cell is a dictionary with its own values.
Each cell is not a dictionary. You can say each row is a dictionary or each column is a dictionary.
Yeah, like each
Okay.
row is a
Cell is
dictionary
just a
and
value.
the inner dictionary is the columns.
Correct. Yeah. And each cell is the actual value that is placed in the inner dictionary. Okay.
Can we have list in like
No.
inside the
List
dictionary?
if you put oh right, you mean like in the matrix if I can put lists as the values in the like cells here if I put a list.
Yes.
That's the question.
Yes.
Yeah, you can put lists as elements, but that's not usually done because it is not required. You can do it.
But then
There's
how
no harm.
then in that case, ma'am, how can they
In the
be
list,
assigned
you
as a
cannot have random access. Okay, you can pick the entire list using random access of the dictionaries. But with inside the list, if you want to find an element, okay, then that you cannot do by random access. That you have to traverse.
Then you can only have random
But
access of the
basically,
list.
there is no such thing. Like I haven't seen at least a matrix of lists. I haven't seen that. But yeah, maybe it's possible.
Ma'am, can we say the intersection of two dictionaries gives a element of a matrix?
Your voice just cut off. Can you repeat?
Ma'am, can we say intersection of two dictionaries gives a...
No, don't use the word intersection. This is not sets, no. Okay, it's better to say that you cannot say intersection because this is
Combination,
nesting.
somewhat combination, like, right, ma'am?
Yeah. So taking both the dictionaries together, you can find an element. Okay. Just like normally you do nested dictionaries. If you want to access a value in a nested dictionary, you have to take both the keys of outer and inner dictionary. No? That's the same thing we're doing here. Okay.
But for that, the key should be different if we want to combine two dictionaries.
Keys are always unique within a dictionary. But between two dictionaries, there can be common keys, right? Like 1, 1 here. Matrix
yes,
1, 1.
Yes, ma'am.
So that
Row
is
and
first row,
column
first
can
column, but
have...
that's fine.
Row
But
and
you
column
cannot have
can
two
have...
rows saying 1, 1. This cannot happen, right? Row and column indices must be unique in themselves.
Yes, ma'am.
Okay. And let's go ahead, otherwise I'll never be able to finish. So dictionaries support random access, create an outer key. See, here in this example, I have said that outer key is corresponding to rows and inner key is corresponding to columns. You can do the reverse also. You can do just here if you want to change it, put columns here and rows here. Okay, same thing. So this is that exact same code only, nothing to say here. Okay, so create a matrix. If you want to create some matrix and use this procedure, so you will just pass the number of rows and number of columns here. Like here I have passed 30 and 45. As 30 is the number of rows, 45 is the number of columns. This is not a square matrix, okay? Square matrix will be 30 cross 30 or 45 cross 45. And this matrix that you create, you're storing it in this variable, my matrix. Okay, so whenever we are calling a procedure and it's returning something, if the procedure returns something, like here the procedure is returning the matrix itself, so you have to store it in some variable, right? That variable here is my matrix. Now,
just
what
one,
do we usually... Yeah.
Sorry. In the non-squared matrix, wherein your number of rows are less than the number of columns, right? Like in the previous case, how do you define or access the element which are not, which don't have a rows, right? We just have a column.
There cannot be elements which don't have rows, no? See, how is this going to work? See, if I have a 2 cross 3 matrix, that is also not squared, right?
Correct.
So there are going to be how many elements? Just you're going to have 6 elements. So if this is column 0, 1, 2, and this is row 0 and 1. So you'll have
Okay.
one element for 0, 0, 0, 1, 0, 2, and then 1, 0, 1, 1, 1, 2.
Oh, got it. Okay. Thank
Okay.
you. Thank you.
Okay. Now, what do we do with matrices? We basically have to do something with the value that is stored in each cell, right?
Each cell, yes,
So how are you going to typically process the elements? You have to go row by row, or you can go column by column. So first thing, I pick a row, like for each row I of my matrix. And then for that row, you can go to
J
the
of my
nested part of it,
matrix.
that is the column. So for each column, J of my matrix. Like in
Yes,
our
ma'am.
example, if I wanted row 1, column 2, then I will say for each row I, this will go like start from 0, 0th index it will start. Okay. And then for that 0th index, it will come inside this for loop, and this inner for is going to iterate through as many times as there are number of columns.
Columns.
Okay. Once
It will
that is
iterate
done,
through every single one.
and you are maybe, let's say I want to find the match for this. Okay, matrix 1, 2. I want to find the value here. But when index I is 0, then for any of the nested iterations, I'm not going to find this. So I have to increment I after I get out of that loop, and then I will become 1. Then again, I will enter the nested for loop. And here again, J will start from 0, 1, 2, and we will finally find this element. So you can do anything using those matrix values. So that's why it is written, do something with my matrix Ij. But
Yes,
how
ma'am.
are you going to access the elements? That is by using nested for loops.
Nested for loops.
And even if you reverse the order, let's say first, instead of I, you take J, and for each element of J, you do it
Yeah,
with
then
I.
just
Same,
write
right?
Ji.
Yeah, that's same, right?
For each column
Yeah.
J and for each column I, do something. Yes, ma'am.
Yeah, thank you.
See, don't confuse this thing. I'm going to repeat this once. If I say outer one is row, okay, and inner one is column, then you have to maintain this. If outer one is row, then this is I, and inner one is column, then this is J. Now, if outer one is your column, okay, that is I is representing your column, then this becomes I, and inner one is representing your row, then this becomes J.
Got it. But what I'm saying is, you can refer J as a column only, but you put the column J first, and then for each of column I of my matrix. So you just reverse the sentence. That's still okay,
Just
right?
reverse it,
Like
yeah.
column, yeah, that's okay. It will yield the same result. This is what I was asking.
Yeah. See, like here, oh, you are saying like the actual element that I'm going to process like this way. No. Here don't change the order. Okay, here keep it Ij.
Yeah. Here the order is same, but even it
You
is
can
IJ.
go, yeah, you can do the processing by doing column first, then row. That is
Correct,
okay.
correct.
Yeah.
Thank you.
So that's why it is mentioned that wherever you are, if you're doing this column first, then just mention for each column J of my matrix, then I go to the row I. Okay.
That's better.
But
Next,
ma'am, in the above pseudocode, for each this one, for each column, for this pseudocode to work betterly, if the rows and columns both have the same number, the row and column number should be same for this code.
if it is a square matrix, you're saying.
Yes, ma'am. Where I'm
This
saying it
will
will
work
not.
for any matrix.
Ma'am, but okay, ma'am, understood.
Yeah, this is general code. See, square matrices are just better to look at. That's why we took those examples. But these codes that we created till now, everything, it will work for any matrix. Okay, any order. Okay. So now it is saying iterating through the rows. Row indices are keys for outer dictionary. So this is the pattern that we are going to maintain even in the questions also. We are going to take the I as row index and J as column index, and we are going to take row as your outer dictionary, and for every row we are going to have nested dictionaries for columns. This is the pattern we are going to follow. If in any question any other kind of pattern is followed, then that will be mentioned. Okay. Okay. Now, row indices are keys. Column indices are keys of first any row. Okay, this up to this. Now, keys of D produces list in arbitrary order. See, for each R in, first of all, keys of my matrix. Now, you tell me, if I have this matrix, my matrix that I just created, what are the keys of my matrix if rows are the outer dictionary, columns are the inner dictionary?
Row numbers.
Row numbers.
So row indices are going to be the keys of my matrix, right? And if I say I want to find, like I want to iterate through each of the columns in row 0, then what are going to be the keys of my matrix 0?
Column?
The keys
Index
of the
column.
row 0.
All the column
column
indices,
number of
right?
0.
So basically my matrix 0 is what? The first in a dictionary. So your 0 is your row number. So for row 0, the inner dictionary that I have is consisting of all columns. So the keys of my matrix 0 is just going to be the column indices. Okay. Why have we sorted them? Because we want to proceed in a sequential manner. We don't want to proceed arbitrarily. If you don't use this sort function, this keys of my matrix will give you the rows in the row indices and the column indices in some arbitrary order, not in sorted order. Okay. That's why we have used the sort function.
Ma'am, but in this, the second code, there will always be the 0, the first row always. If we
For this
use
line,
this.
you're saying?
Yes, ma'am.
In this line, this is for row 0. Okay.
Yes,
You
ma'am.
can do this for row 1, row 2, anything.
So
Okay, this is
these,
just a sample code.
so in the 0 we can change it. This
Yeah,
0
here,
which is written.
if you want to do it for column, I'm sorry, let's say you want to do it for row 1. Okay, so we start from row 0. So index I is first 0. Then whatever you want to do here, you do that operation. And then once you come out of this loop, you increment I.
Yes,
So
ma'am.
next time when you go to the inner for loop here, this will be incremented to 1. So now
Yes,
you're
ma'am.
finding for row 1 and all the columns in that row.
Ma'am,
Clear?
but what if we put R in it, in my matrix, a square bracket R, then
Square
will it
bracket
give the same result?
R.
Because R is the key.
Yeah,
R is the
that is what
entire row, ma'am.
See, for each R in sort keys matrix, this is actually what? Every
An entire row.
index,
Yeah, ma'am.
every row index. Okay.
Yes, ma'am.
So if you want to put that, that is what we actually want. Now we want to put the row index here only. That's why I said this is for a single row they have shown. Okay. If you want to generalize this code, just place R in the square brackets and then just increment R
Ma'am,
here
R
instead of
won't
I.
work, ma'am,
Okay, ma'am,
because R
understood.
is
Yes,
not the
ma'am.
key, ma'am. R is the entire row.
R is the index of the row.
Ma'am, when you say for each R in sort of keys, ma'am, so it is not giving us the. Okay,
First, you tell me what is keys of my
Correct,
matrix.
correct.
These are the
Keys
indices,
are
na?
the row,
Right,
column,
ma'am,
number
right.
of row.
So you can just put R here and instead of I, if you're doing R representation,
Yeah,
just
ma'am.
increment R here.
Got you.
Yes, ma'am.
Got
We
your
can
point.
increment. Okay, ma'am. So
Yeah.
because it is not incrementing, so we are putting 0 as default.
This is just sample code to show you how to access elements. Okay.
Okay, ma'am. Thank you.
Now, keys of D, always remember whenever we are creating a matrix, if we use the key function on that, it will give us the list elements or the keys in arbitrary order. Okay, that's why we are using sort function so that we can start from 0, 1, 2, 3, it goes in this order. So keys D produces a list in arbitrary order. Assume a suitable sort procedure. Okay, so sort of keys D will give me the keys in ascending order. Next is to improve readability, we can use just these two. Okay, rows and columns. So just so that you don't get confused, what we can do is for each R in rows of my matrix. So this part is, this rows of my matrix is basically just representing this thing. Okay, so instead of writing sort of keys of my matrix, we are just writing rows of my matrix. This basically means that it is doing the same thing, that is taking the keys, the row indices and sorting them in ascending order and then using each key in each for each block. Okay. Similarly, for columns, we are going to implement this using this columns function. Okay, this is just to make the expression clear, more readable. Now, there's some actual code. Right. Okay, so a little summary is that matrices are what? Two-dimensional tables. Two-dimensional, what are the two dimensions? Rows and columns. Support random access to any element. So we can access any element by row and column indices if we know. And we can implement matrices using nested dictionaries. Again, you can do it in any order. Outer dictionary can be either for row or column and correspondingly inner one will change. use iterators to process matrices row-wise and column-wise. So for each row, for each R in rows of my matrix, this is going to traverse through a list of keys of the outer dictionary, which is nothing but your row indices. And for each of those row indices, you can again come to columns of my matrix. That is, for each row, you can again traverse through the list of keys of columns, column indices. So matrices, why we are learning about matrices? Because now we are going to use matrices to represent graphs. So we are first using dictionaries to implement matrices and matrices to implement graphs. Okay, that's our main goal. Like week 9 is about graphs only. So is this slide all clear? Any questions from here till now?
Ma'am, this line for each R in rows, this is the line to improve the
Yeah,
readability.
improve readability, correct. Basically,
Yes,
this
ma'am.
rows of my matrix is nothing but sort of keys of my matrix. That thing.
Sort of keys of matrix.
Yeah.
Okay, ma'am. Okay, ma'am.
Any other question from what we have done so far? Should I go to the next slide?
Yes, ma'am.
Yes, ma'am.
Okay, size is big enough. You can read.
Yes, ma'am.
Hello, is anyone here or is my audio and video glitching?
Your audio is glitching.
And your voice is not coming.
Same problem I have. I have the same problem. I can't
I think
hear
ma'am is not. I think
Yeah, am
ma'am is
I
not
audible now?
speaking something.
Yes, ma'am,
Yes,
you're
yes,
audible.
ma'am.
Yes,
You are
ma'am.
audible.
Yes,
Ma'am.
My internet is
Anirudh,
a little unstable today. So
Anirudh's voice
Anirudh,
is glitching.
And there will be a.
okay, is my voice audible now?
Yes, ma'am.
Yes, ma'am.
It is audible.
Okay, you just let me know. Just do one thing. If my voice cuts up, just write it in the chat box. Okay, so I can tell.
Okay.
Okay, sure, ma'am.
Okay, ma'am.
Yeah. Okay.
Yes.
Now this part is very interesting. Okay, now we are going to solve some actual representations of matrices and how we are going to work with that. So we are going to have this problem statement for finding mentors for students. Okay, if I've gone through the lectures, you know
Yes,
that
ma'am.
we are going to use the scores dataset to find mentors for students in each subject.
Yes.
So who are these mentors? Basically, if you're a student who has scored, say, 60 in mathematics, okay, and there is your friend who has scored 80 in mathematics. So this friend of yours can now mentor you based on what criteria? That he has scored at least 10 marks more than you, but at most 20 marks more than you, not more than that. Why we have this criteria? Because if someone is going to mentor you, they have to be better than you in that subject. So at least they have to have scored 10 marks more than you in the particular subject. And why less? Why not more than 20? Because so that,
the student
It
does
person
will
is
be
not
harder to
intimidated.
understand.
Yes. So the person is not intimidated. So basically, the range to find mentors of a student is that all the students that have scored 10 to 20 marks more than that person in that subject. Okay. So this is the problem statement. Now, see, student A can mentor student B in a subject if A has higher marks, but not too much higher. So difference is going to be 10 to 20 marks. So it has to be greater than 10, like it has to be at least 10 and it can be at most 20. Not, the difference cannot be anything other than this. Now, so if you are a student who has scored 50 in chemistry, then who can you mentor? You can mentor people who have scored 30 to 40 marks. Right? So you can mentor this batch. Why? Because people who have scored 40, with them you have a 10 marks gap. And then people who have scored 30, with them you have a max of 20 marks gap, and anyone in between you can also mentor. Is the problem clear?
Yes, ma'am.
For everyone, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes,
Thanks.
ma'am.
Now let's write the pseudocode for this. So student A can mentor student B in a subject if A has higher marks, but not too much higher. Create a dictionary for marks in a subject. Now, first of all, how will I know that who has what marks? So for that, I'm going to create a dictionary for each subject where the key of the dictionary is going to be the sequence number of that student's card. Okay, that is the key. So every key is unique. So every sequence number is also unique. Now, what is the value? For every sequence number, like say if I want to create this dictionary of read marks for mathematics subject, that is I want to find the marks scored by each student in maths. So there the sequence number will be their student sequence number or card sequence numbers, and the corresponding value will be the marks that they have scored in maths. Okay. So how are we implementing? Just a simple procedure, read marks subject. Here in subject, you can pass any subject as parameter. Then inside the procedure, we are going to implement an empty dictionary called marks. Okay, once this is initialized, then you have your while loop. This while loop is traversing through which data set? Scores data set. Okay, so table 1 has more rows is nothing but the scores data set only. Now you're going to pick one card from that data set, and this is what? Assigning key value pair, right? So marks x dot sequence number, that is whoever's card you pick, that student sequence number is becoming the key, and corresponding value will be that student's marks in the particular subject that you chose. So x dot subject. Okay, so if we are doing for maths, this is sequence number is to maths marks. Like this, it will iterate how many times? There are, I think, 30 cards in scores data set, so 30 times. Clear? So this is your read marks procedure. You can run this for maths, physics, chemistry, anything, or even total marks. Clear this part? Any question?
Ma'am, you have said earlier that keys are consist only arbitrary values, and now you have used X sequence number, which
No.
is
Keys contain arbitrary. I didn't say keys contain arbitrary values. I said that keys have to be unique. Now, if in a matrix setting, you want to use that keys function to find the keys of the matrix, then it will give the keys in an arbitrary order, not values. Okay. That's why we use that sort function to sort the keys in the arbitrary order into ascending order. Okay. Keys are always going to be unique. That is the one condition. In a dictionary, all keys are going to be totally unique, no duplicates.
And
so
then,
sequence number for each card is also unique, no?
And then what do you mean by arbitrary? Well,
Arbitrary means in random order. Okay. So, like in the last PDF we saw, right? So for that dictionary, for that matrix that I created, you tell me what were the column indices? There are 3 columns, so 0, 1, 2 were the indices, right?
Yes, ma'am.
These are the keys for inner dictionary, correct? So if I just did this, keys of columns, this should return me a list of keys of that inner dictionary, right? But this list can come in any order. It can come as 201. Okay. So I'm just sorting this list using this sort function. Okay. So that it comes in the ascending order 0, 1, 2. This order is arbitrary order. It can be anything. Clear?
Okay.
But keys are always going to be unique. So that's why we are using this sequence number from each card, because sequence number is unique for every student, right? Anything else from this procedure that you didn't understand? Anyone?
No, ma'am.
One question on this keys of.
So what is this procedure returning?
The
Marks.
a dictionary which contains
Marks
of the
That
student.
is created, right?
Sequence number
This
as a keys and subject as a value.
correct. So sequence number as keys, marks of the subject as the values. In which dictionary? Marks dictionary. This dictionary is being returned by this read marks procedure. Okay, and where is this being stored? Here, math marks. Because here I called this procedure, right? So the return value, whatever it is, it will be stored in this variable. Now we are going to apply this read marks that we created and use that dictionary in the mentoring problem. How are we going to do that? See, this is the procedure to create mentor graph. So mentor graph basically means what? See, if there are two students, A and B. Okay. Now A has scored 80 in maths, B has scored 65. So according to our criteria, what is it? That the
A can
difference,
mentor B.
right? So the difference between A and B is greater than 10 or at least 10, and it is also at most 20. That is, the difference is 15 here. So I
15,
can
yes,
say
ma'am.
that A can mentor B, right? So this is actually a part of a graph, right? Again, let's say this is for, let's say, math subject. Okay. Now in physics, B has scored in physics 80, but A has scored in physics 65. So B can mentor A in
Mentor A in
physics.
physics, yes, ma'am.
This created a cycle now, right? So this is what, these are all parts of graphs only. So each student is actually a node in the graph. Okay. Each sequence number is actually a node in the graph.
And it can have different labels.
Yeah. So now the procedure, create mentor graph. So this is the graph that I want to create. Okay. I want to create a graph to see which student is mentoring which student, and what am I passing as my argument? The marks dictionary that I created, right? Marks dictionary was created where? In this read marks procedure, this one. So let's say I want to find the mentor graph for mathematics subject. Okay. So first I have to create the marks dictionary for math subject, where I will store the marks of every student in maths. That is stored where? In this math marks variable, correct? Now, if I want to find the mentor graph, that is who is mentoring who in math subject, then I'm going to pass that marks dictionary as an argument in this procedure. Clear?
Yes, ma'am.
Yes, ma'am.
Now, in the procedure, what I'm doing, see, first, n is a variable which is assigned length of keys of marks. So tell me one thing, if there are 30 students in my data set, how many keys are going to be there in the dictionary?
30.
30 keys.
30.
So length will be what? N will be 30.
30.
30 distinct keys, 30 distinct sequence numbers, right? So n is 30. Next, mentor graph. In this mentor graph variable, I am calling a procedure called create matrix nn. This procedure is going to do what?
Create a square matrix.
Create a square
Initialize
matrix
to
of
0.
order. What is the order?
N cross N.
N
30 cross 30.
30
sorry.
cross 30.
30 cross 10.
Good. So n cross n, this is a square matrix I'm creating. Now, when I create the matrix, we saw the procedure for create matrix. Now, after it is created, this 30 cross 30 matrix, what are the values in each cell?
0.
0.
Initialize to 0.
Right.
0.
So we made a
In this it is
null
1.
matrix, right?
Ma'am, in this it is 1. Acha, in the older one we are storing 0.
See, the create matrix procedure is the one we did at the beginning. Okay. So every time we create a matrix and we haven't assigned values yet, it is by default, all the cells are going to have 0 values. Okay.
Yes, ma'am.
Now, for each I in keys of marks. So keys of marks is giving what? Sequence numbers of students?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So for
In rows.
every student, okay. For every student in the marks dictionary, we are going to check with all other students. So if there are 30 students, I picked the first student here. So I is currently 1. Okay. This is the first student, I is 1. Now for I1, then I will enter this nested for, where for each j in keys marks, this j is going to be, it will iterate how many times?
I mean, all the number 29 times. 29 times.
30 times, man.
It will iterate 30
29.
times actually. Why?
0 to 29.
Okay, it will
Because
Keys of
keys
marks
are
is
Comparing
30.
to all the students.
comparing to everyone. So he will
Yes,
compare
ma'am.
with himself also actually, right?
So
Because whenever we say
J in this? What is the value of J in the first?
I in the first is, okay, for the first iteration, I is say 1, sequence number 1. Okay. Now for that sequence number, I am going to compare his mathematics marks with every other student, including himself. Why including himself? Because I am saying for each j in keys of j, keys of marks. Keys of marks is going to give me that same list, that same list of sequence numbers. So it will go through every 30 student, including himself, right? So for each I, how many times is the inner loop iterating?
30 times.
30 times.
So in total, how many iterations are there?
900 times.
900.
30 into 30,
30
ma'am.
into 30. Right.
Yes, ma'am.
So after this J, okay, now let's say this for the first iteration, I is 1 and then it came to the inner for and now J is also 1. Now for the same person, okay, for the same person, what will be the marks difference?
Zero.
Zero. Zero.
Ma'am, zero.
So if marks difference is 0, then you come to this if block
No, ma'am.
where ij marks difference has to be greater than equal to 10 and less than equal to 20.
Yeah.
So 0 is not in any of this range, so
False.
nothing will happen. So
Yes,
it will
ma'am.
just automatically go to the next iteration in inner for. So now j is what? 2. That is the second student. Okay.
Yeah.
Now let's say the first student had scored 80 and the second student, this is all for mathematics we are doing currently. Okay. First student has scored 80. Second student that I have picked in J now has scored 66. So now what is the marks difference? 14.
Yeah.
This marks I minus marks J is giving me 14. Right? So what is IJ marks difference? It is 14. So is it greater than 10? Greater than or
Yes.
equal to 10? Yes. Is it less
Yes,
than equal to
ma'am.
20? Yes. So it is joined by an AND. That means both of these conditions have to be satisfied. Okay. So this is satisfying both. So in the mentor graph, which is basically the matrix that we created, n cross n matrix, this one, we are calling it mentor graph. So in this mentor graph matrix, IJ value will be assigned 1. Okay. This 1
Yes.
means what? There is an edge from
Connection
student
between
1
I
to
to J.
student 2 or student I to student J, which means that student I is mentoring student J. Clear?
Yes.
Ma'am, why we assigning 1?
1 is to show that there is an edge in the actual graph between I and J. Initially, it was all 0. So after this procedure is completed, only those cells will have 1 where I is mentoring J. Like if student 2 is mentoring student 5, then at matrix IJ, that is 2, 5, mentor graph 2, 5, that cell will have the value 1. Okay. And those who are not mentoring, they are going to have value 0. Like if student 6 is not mentoring student 8, then mentor graph 6, 8 is going to have value 0. Clear? But if
Okay,
student 8 is mentoring student 6, then mentor graph 8, 6 is going to have value 1. Clear?
Clear, ma'am. Clear.
Yeah, Veda.
So in this way, we are going to fill in this ones wherever it is required, right? Wherever there are mentor-mentee relationships. And in the end, I'm going to return this mentor graph. Okay. So this for maths marks, it will return mentor graph for math. For physics, it will do chemistry same way. So
Ma'am,
Mij.
Ma'am,
Yeah.
we will get only an individual value here after return mentor graph.
You are getting the entire matrix.
Ma'am, but like for first student, the value will be 1, right? As you said, mentor graph ij is equal to 1. Then
Yeah. So
for
if
the
that
second
cell,
value,
the value is 1. You are returning what? You are returning the entire mentor graph thing. Na? What is mentor graph storing? This matrix that we created. So it is returning the entire matrix after you have updated the values.
there is a variable ij, so it will change according to that, right?
Yes, yes. So here you are going to find all the valid mentor-mentee relationships, and wherever there is a student I mentoring a student J, in that place in mentor graph IJ, you are going to put 1. Clear? Now, after this is done for all the students, you are going to return this mentor graph. This entire matrix you are returning.
Ma'am, means the mentor graph is the matrix which has all the values as 0.
That's what I said. No, that matrix we are learning matrix to represent graphs.
Yes, ma'am. So create a matrix is the previous function which we used.
So this I and J are nothing but graph nodes. Okay. Student I and student J are just nodes of the graph.
Yes, ma'am.
So mentor graph would
if I
And
say
so ment graph will be providing a matrix or a graph.
a matrix, see the representation is matrix, but it is trying to show a graph. We are implementing the graph in matrix format.
Wherever
So
there will be
then
one, it will be
the
edges, right?
element
There is
of
the
matrix
connections
will
are
be
One by
0,
one,
1,
one by one.
0, 0, 1, 0.
It can be anything. It depends. See, if there are 4 students in my data set. Okay. So this is sequence number 0, 1, 2, 3. Here also sequence number 0, 1, 2, 3. So initially they are all zeros. Okay. Initially I created the matrix. They are all zeros. Now I found out using this if condition here that student with sequence number 1 is mentoring student with sequence number 2. So sequence number 1 is mentoring sequence number 2. So this cell, that means this one, will be changed to 1 instead of 0. Understood?
Yes,
Yes,
ma'am.
ma'am.
Got
Similarly, if
it.
I find that 2 is mentoring 3, so here I will have 1 instead of 0. That's what happened. That is what is happening. Every 1 represents an edge. Okay, an edge from I to j. So wherever I find that matrix ij is 1, it means there is an edge from I to j. What is edge representing? That I is mentoring j. Okay, and if there is no edge, then the value remains 0 in that cell.
But here we are not taking from J to I, right? At all. There might be a
No,
possibility.
j to I, no. In like throughout our course, we are only going to use this convention that I is row, j is column, and ij we are going to find.
No, but as example in the previous cycle
No,
example
no.
that we
Oh,
showed.
okay, you're saying that j to I am going to see that like if 1 mentors 2 and then again 2 if mentors 1.
No, 2 is mentor 2, let's say, right? So we are not checking that. So that will not come because we are not checking otherwise, right? Like in the previous example, you showed that in the mathematics, 1 is mentoring 2. A is like, and in the physics, B is B is mentoring A.
In a particular subject, if student 1 is mentoring student 2, it means obviously student 2 has less marks, so he cannot mentor
Correct.
student 1.
Yeah, but for the next subject, then we have to repeat this whole code for the next subject and do J to I checking. Is that what will happen?
Whenever you are checking, we are going through all the keys anyway. So you are going to go through all the sequence numbers anyway. Okay. Like if you are
Okay, so
checking from 1
me
and
re-
2,
Ma'am actually is getting confused between the adjacency matrix for each subject. He's thinking
yeah,
there is
that is
just
for each
one
subject.
There
adjacency.
will be only one relation, ma'am,
See,
in one subject.
this is maths. This is just for maths, I'm saying. You can do this entire thing for physics, entire thing for chemistry. But the thing is that if there is an edge between mij here, okay, in this subject, I'm saying, if there is an edge between mij, that is student I is mentoring student j in maths, then there is 1 in that corresponding cell. But it will never be possible to have mji as 1 as well. Like if student 1 is mentoring student 2, then there is an edge from 1 to 2 in subject maths. So in that same subject, 2 can never be mentoring 1.
Got it. I
Like
think I
in a
was
different subject, it can happen.
yeah, rows and columns actually are the same student. So 1 on 1 column also,
Yeah.
Same
it is
students.
actually the same student. So
Same
if you want
students,
to do
yes,
it
all
for a
sequence
different
numbers.
subject, you have to
It
repeat the
is
code for a
directed
different.
edge.
Yes.
Yes.
It is
Yes.
Thank you,
directed edge.
ma'am. Thank you, students.
Yeah, this is the directed edge. Okay. Directed,
Can we
undirected,
say
I haven't mentioned yet, so I'm not saying anything. Just wait a little.
so? Can we say mentor graph is like a dictionary of dictionary? Like there are 3
Mental
dictionaries.
graph is just a nested dictionary, like we did. Okay. That
It
matrix
has
only
like
is
2
mental graph.
dictionaries inside it of I and J.
See, the original create matrix procedure, right? It was what? Dictionary within a dictionary. That is for each outer dictionary key, there was an inner dictionary. That same thing is implemented here. This create matrix NN is returning this n cross n matrix, which is stored in mentor graph. We are calling this matrix mentor graph. Okay. Exactly same thing. Nothing changed. That same nested dictionary. Just here,
Clear,
instead
ma'am.
of rows and columns, you can think of those rows and column indices as sequence numbers of students. Okay.
Ma'am, I have one doubt. Ma'am, for example, if we are considering, suppose we are getting a matrix, so matrix 1 and 2, the value of this will be 1. For example, if 1 is mentoring 2, then that means value of
Matrix
that
1, 2 is 1. Yes,
so
that cell is containing 1.
that means matrix 2 1 it will be 0, no?
Always, yes. In a particular subject, always.
Okay, ma'am.
And the diagonal will be zeros, no? The 0 to 3.
Yeah, always. The principal diagonal is always going to be 0 because no student is going to mentor himself. So 2, 2, 3, 3, these things will always be 0. Okay. Yeah, see this one. So A can mentor student B in one subject, but B can mentor student A in another. Like I took that example. A is mentoring B in maths, but B is again mentoring A in physics. Okay, this can happen. So they're saying study groups in maths and physics. We want to form this study group in maths and physics. We want to know who is mentoring who across two subjects, maths and physics. How are we doing that? First, you are going to create two read marks dictionaries, right? One for maths, one for physics. These dictionaries are containing nothing but sequence number is to marks in a subject maths and subject physics for all students, right? And they are stored in maths marks and physics marks. Then you create these mentor graphs for math and for physics that we just saw. Those mentor graphs that who is mentoring who in maths and physics. Okay. Next, we are doing what? We are having a paired dictionary. What is this dictionary going to do? So using the mentor graphs, we are going to pair off students. How? Like if A is mentoring B in maths and B is mentoring A in physics. So A and B can be a pair. There is a cycle between A
Yes.
and B, right?
Yes, ma'am.
So we want to find such pairs. And that pair we will store in this paired dictionary. How we are doing that? See, up to this is clear, right? Up to this.
Yes, ma'am.
Okay.
Yes, ma'am.
Next, we come to this for each block. So for each I in rows of math mentor graph. So we saw this rows function is nothing but sorted keys of math mentor graph, right?
Mm.
Sorted indices. So for each of such indices or sequence number in this case, we are going to again have a nested if. So for each j in columns, this is for math we are doing first. Okay. So in this math mentor graph matrix that we created, where only those cells are one, where A is mentoring, where I is mentoring J, so IJ cell is one. Okay. So first we picked the I index. Let's say first index is 0. Okay. For first iteration, I is 0. Agreed?
Yes.
Next, if I enter this nested loop, for each J in columns, J is also starting
0.
from 0.
Yeah.
0, yeah.
First, both are 0, 0. Now I am going to come into this block. So if math mentor graph IJ is equal to 1. So for 0, 0, it is checking if it is equal to 1. And physics mentor graph JI is equal to 1. So here also 0, 0 is equal to 1. Okay, what does this mean? Math mentor graph 0, 0 is equal to 1. First of all, tell me, is this ever going to happen?
No,
No, ma'am. 0, 0 is the
No,
same
ma'am.
student.
No,
0
ma'am.
is the same
Never
student.
gonna happen.
So for him, none of this is true. So even if one of the condition is broken and it is all connected by ANDs, that means this whole thing is false, right?
Yes.
So
Yes,
these
ma'am.
two values will not be updated. So let's just take a valid iteration where this will work. That is the next iteration where J is 1. Okay, so outer iteration still going on. I is 0. Now J is incremented to 1.
1, yeah.
So now you check if math mentor graph IJ, that is 0, 1 is 1. That is student 0 mentoring student 1 in math.
It
If
is
yes.
not
Okay,
actually
if yes.
incremented, right? It is actually the value of that, right? It is not incremented. It is
Whenever you are
value.
putting for each block, it means that for loop means incrementation is going to happen for every iteration.
No, is it the next value? It is not incrementation. It is the next value of that sequence number.
Next value you are going how? You're incrementing the index. That's why we have the sorted order, no?
Okay, incrementing the index. Okay, not
Yes.
actual value. Yeah, yeah.
No, not actual value. I'm saying index.
Yeah, yeah. Okay.
Okay. So math mentor graph 0, 1. That means if 0th student is mentoring ith student, then I have a 1 in that cell, right? And I'm going to check in physics mentor graph that I prepared here. If 1, 0, that is if student 1 is mentoring student 0 in physics, then also there is going to be a 1 in 1, 0 element, right? In physics mentor graph. And not is key paired I, that is I and J are not yet keys of this paired dictionary. That is, they are not yet present in the paired dictionary, right? Then you are going to do this assignment that paired I is going to have J value and paired J is going to have I value. So basically in this paired dictionary, you tell me, what are the keys again of this paired dictionary? The student sequence numbers.
Yeah.
right? I and J are that only. Student sequence number is also starting from 0 only, na?
Yes, ma'am.
Yeah.
Yes, ma'am.
So in this paired dictionary, we are trying to find such pairs who are mentoring each other in maths and physics. Okay.
Yes,
So we are
ma'am.
going to check 4 conditions in this if block. First condition is that we are going to check if I is mentoring J in maths. If yes, then I am going to check if J is mentoring I in physics. If that is also true, then I am going to check are I and J already part of paired dictionary? That is, are they already paired with someone? If not, if both of them are available, that is, they are not keys of paired yet, then I'm going to assign them to each other. So for I key in paired index, the value is going to be J. And for J key in paired dictionary, the value is going to be I. That is, I is paired with J and J is paired with I. So now I and J are blocked. Okay. That means
Ma'am,
if
can
this
you
was
explain
true,
the if block?
yeah.
Ma'am,
Okay.
can you
So,
re-explain the if block?
yeah, I'm taking. So,
Ma'am, that means all the 4 conditions should be true.
yeah, all
After
4
that,
should be true.
yes, then
Okay.
we will
Why
have an
both?
element in paired dictionary.
Let me explain the if part again once.
Ma'am, why
So
we use not is key paired I and
I
paired J?
will say, I will tell you everything. Just let me explain from the beginning this if part. Okay. So first of all, whoever asked me to explain the if block, so math mentor graph and physics mentor graph is clear to you, right? What these are storing?
Yes,
This
ma'am.
is
Yes,
just
ma'am.
data about who is mentoring who in maths and physics.
Yes,
So
ma'am.
for
Yes,
I0,
ma'am.
that is student with sequence number 0, and J1, that is student with sequence number 1. Okay. We are checking if math mentor graph IJ is 1. So where is 1 given in the matrix? Where there is a mentor relationship. That is, if I0 and J1, that is student 0 is mentoring student 1 in math, then there is going to be a 1 in the corresponding cell. If this is true, then we are going to check the next condition, that in physics mentor graph is student 1 mentoring student 0. That is the other way around. Okay. If this is also 1, that is both are mentoring each other in 2 separate subjects, maths and physics. And then I have to check that both of them are not yet keys of the paired dictionary. Okay, why are we checking this? Because if I or J are paired with someone else already, like, for example, take if this student I, that is with sequence number 0, has scored 18 math. Okay. Now student J with sequence number 1 has scored 75 in, 17 math. Okay. That means I can mentor J. True.
Yes, ma'am.
Yeah.
Yes,
But there
ma'am.
can be another student with sequence number 2 who has scored 65 in math. So I can also mentor this student, K, some
Yes.
K, let's say.
Yes, ma'am.
So that is why it is important to find the pairings, that whether they are already present. Okay. If they're already present, I won't make that pair again. So first, I create these paired dictionary entries for I and J, since they are not keys. So initially, paired dictionary is empty, right? After the first iteration, I'm not going to find I and J as keys of this dictionary. It is empty. So I'm going to create those key value pairs. What are the key value
Ma'am,
pairs?
so ma'am, so only one student can mentor one student.
Yeah, in this one, it is going to be distinct. Okay, if I is mentoring J and J is mentoring I, this has to be distinct. I cannot be paired with anyone else here.
Okay. Okay.
Because keys are going to have to be unique, na?
Ma'am, then for example, that you have given, paired dictionary will have the values 6, 1 and 6, 2 also.
This is 0, okay, not 6. Okay.
Oh,
Yeah,
say
0,
0.
1 and 1, 0 is going, I'm sorry. So paired dictionary will have two keys, 0 and 1, right? So for 0 key, the value is going to be 1, and for 1 key, the value is going to be 0.
So the
Okay.
mentorship is happening only based on their appearance, how early they appear.
Yes, exactly. So who
Irrespective
is
of
appearing
difference.
first?
Irrespective
Yes.
of difference on the mark. Later they found
Yes.
it will not take
But
that. Okay.
no. That is why the difference thing is not mentioned here, because that difference thing is only checked while we are creating the mentor graphs themselves.
Okay.
Okay. That is where we need that difference. Once it is created, now I need to have unique pairs, because cycles are formed like this. Now between two nodes, I am having cycles here. because I am only checking for 2 subjects. Now, it is obviously possible that a person is mentoring more than 1 people, but it
Correct.
depends on in which order those people are coming when I am checking for pairs. Okay, so the first pairing that I
Yes,
find
ma'am.
that is valid, that I will assign in the paired dictionary. Now, after
Ma'am,
this, when I increment j again, j
Ma'am,
becomes 2.
ma'am, so
Yeah,
we can also store a list in that pair. If 0 is mentoring 1 and 2, so we can store list
possible,
in
but that is not
that
what we are
dictionary with
doing.
key.
Yeah,
But since it will give us the same key value.
ma'am,
see,
if,
don't
ma'am,
If one come first, ma'am, if one come first, so we are just storing that value. And if
yes.
second come later after that, so we cannot store 2 in that
That's what I
0
was trying
related
to
to
that's what I was
2 and
trying to
2
show.
is
Let's
related
first
to 1.
see, let me finish this. So if I is still 0, now j is again incremented to the next one. Okay, or j is going to the next value of column index, so that is 2. So student 0 has also mentored student 2, so math mentor graph is giving correct. So 0 2, this is going to have some 1 entry, right? Let's say in physics mentor graph also I see that student 2 is mentoring student 0. So here also I have a 1. Okay, so student 2 is mentoring student 0. Here also I have a 1. But when I come here, is key, paired I. So I is already paired with 1, right?
Yes.
So I is already a key. So this condition is going to be false. Okay, and
Yes.
even if
Yes.
one condition is false, then the whole thing is false because it's joined by ands.
Yeah. Yeah.
This is why this key value pairing, the pairs are going to be unique. Okay, even if one student is mentoring more than one students.
Yes, ma'am, understood.
Okay.
Ma'am,
Got it, ma'am.
understood.
Got it. Got it.
Ma'am,
Got it.
Okay, is this
in
code any other questions?
paired dictionary,
ma'am,
Yeah,
ma'am,
let
in
her finish
paired
first.
dictionary, will I be key or J be key?
In paired dictionary, this one, you're
Yeah,
asking this one.
the empty one.
Yeah, the empty one.
Yeah,
So
ma'am.
I and J are what? Sequence numbers. So the keys are sequence numbers. Both I and J are going to be key. Okay, see here. If I and J are not keys, but they are mentoring each other in maths and physics, then I'm going to create those keys. One for I, one for J. And the corresponding value will be the other person. So if for I key, I and J are a pair, right? So for I key, the value is J, and for J key, the value is I.
ma'am, first we found that 0 is mentoring 1 in physics, and after that 0 cannot mentor 2 in other subject.
No, first we found 0 is mentoring 2 in maths. And we
Okay.
found 2 is mentoring 0 in physics.
No,
This is
ma'am.
possible. Across subjects, I can do it.
No, ma'am. I'm saying 0 is mentoring 1 in like mathematics. Then we found this first, and again I have found a pair like 0 is mentoring 2 in other subject. So 0 and 2, this pair will not be there in the pair dictionary, right? Because it is occurring secondly.
Okay. Like you are saying that 0 is mentoring 2 in maths as well as physics.
No, I'm saying first I have found a pair of 0, 1 and
See, a
0 is
pair, you can only
mentoring.
call it a pair when both are mentoring each other.
Oh, sorry. Ma'am, I have found 0 is mentoring 1 in like mathematics, and 0 is also mentoring 2 in physics. And the
You're right, Mr. Mandar. It will not, because it is appearing second time. So first is
Yeah.
already paired, so it will not have. You're right.
Yes,
Even more important point than that is you first have to check whether 1 is also mentoring 0 in physics. If 1 is not mentoring 0 in physics, then there is an opening for 0 to pair with 2.
Yeah.
Correct.
Okay, so you have to check both the conditions first.
Both are the keys. Both will
Yes.
get set
All
as
the
the
sequence
keys.
numbers are unique keys. Okay, we are trying to find all sequence numbers pairs. Who is paired with who?
I have a question, ma'am. Ma'am, in the beginning, you have written like for each I in rows math mentor graph, and then again took the math mentor graphs columns. So here, can we take the
Physics mentor graph
marks?
also you can use. Yeah,
It is
anything.
okay, right?
We just want to go through the sequence numbers. That's it.
Oh, because both the keys will be
Yeah, both
same
are
in the
going to
both.
be same keys. Yes, correct.
Okay, ma'am.
So it will
Anything
just
else?
pair whatever happens first. Like even if
Yeah.
math
Whichever
0 will
pair I
have a pair
find first.
later, then it won't consider it.
look, if this happens that 0 is mentoring 1 in math, but when I checked in physics mentor graph, 1 is not mentoring 0 in physics. So that is not a pair. So now 0 and 1 are still open for pairing. Understood? Next, if I
Mutual
find
pair.
that 0,
Yes.
0 is mentoring 2 in maths and 2 is mentoring 0 in physics, this is now a pair. So now what will be the key value pair in paired? 0 is to 2 and 2 is to 0. Understood?
So
But
if
if there,
we
but
chase
if
the physics first and math second, then we may have a possibility of having different pairing, right? Because
You
what will
can,
appear
yes.
first?
Yeah,
Okay.
it will be
Yes.
reverse. It will be
yes,
entire reverse, the opposite.
Yeah, entire thing will be changed. Then you have to, this totally depends on the order which is coming first.
Correct. Thank you.
Okay.
May I say
Okay. Anything else from here? Pairing.
so it
code?
won't be efficient, right? Because maybe there would be a better pair afterwards, which have like a more
This
difference,
is
like
not
not of
efficient.
10, but then it of 20 marks.
Okay,
But it won't consider
see, there is
because
actually no
already
such
it's paired.
criteria to know which is a better pair. Okay, we don't know who is a better pair. That depends on their performance. We are not taking that as a metric here. Okay, that
Ma'am,
marks difference is not deciding who is a better pair. It is just a criteria. Okay,
ma'am,
there are
we
no
will
better
have
pairs.
two values for, let us say, we found a pair. So in paired dictionary, we will have two elements.
Hmm.
Two elements.
Two key value pairs.
Yes, for a pair.
Yes, for a pair, actually there are two key value pairs in the paired dictionary.
Okay. Thank you.
Okay. Anything else?
May I say?
This is clear, right, everyone? Everything, everybody is solved.
Yes.
So, ma'am,
Yes,
just
ma'am.
one. So, this paired dictionary will consist like 0, 1, 1, 0, 2, 3, 3, 2.
3, 2.
This type. Okay.
Correct.
It will not consist like 2, 0, 0, 2. Like 2, 3.
2003. This is not going to happen. Okay. Only I and J are going to be paired with each other only.
Okay. Got it. Thank you.
Okay. Now, next concept is who are the popular students. So, popular students are those students who are mentored by many. Okay. And also mentor many people. So, basically, the students who are related to the maximum number of students. So, here we are taking only one criteria. I think they have mentioned that a student who can be mentored by many people is popular. Okay. So if A is mentored by B, C, D, so there are all incoming edges. See, B is mentoring A, C is mentoring A, D is mentoring A. So A is a popular student. Okay. The more incoming edges it has, the more popular it is. Understood? So now how are we going to implement this? See, first I have this code math marks. This is doing what? This is storing all the marks from mathematics, right? Sequence numbered is to marks, that dictionary. Next, physics marks is having physics and chemistry for chemistry.
Yeah.
Next, I am creating mentor graphs for all three subjects. That is, who is mentoring who in that subject, right? Then here, this is the popularity, to find the popularity. Okay, who are the popular students? So count incoming mentoring edges for all students. Okay, so the student who has the maximum number of incoming edges is the most popular student. That is the student who is mentored by the maximum number of people. Now you might say that there are only 3 subjects, right? So a student A is
Yes,
mentored
ma'am.
by at max 3 people. No. In one subject also, he can be mentored by many people who have scored higher than him within that criteria, right? Like if A has scored, let's say, 40 marks in chemistry. Okay. B has scored 65 in chemistry and C has scored 68 in chemistry. So both B and C can mentor him, right? I'm sorry,
Yes.
this is not possible. See, this is
No, ma'am,
breaking the
there difference
criteria. You should
getting.
have stopped me. Here. This is, I can say, 55 and 58. This is okay,
Yeah.
right? Because
Yeah.
criteria is what? Greater than equal to 10 and less than equal to 20. This is the criteria of difference.
Yes.
Okay, so both B and C in chemistry can mentor A. So there can be more than one people mentoring a single person in a single subject. So the most number of incoming edges, that person is the most popular. So popularity is first what? a dictionary, empty
But
dictionary.
ma'am, for popular students, we don't have a upper limit, like more than the marks of the student.
I don't understand the question.
Ma'am, I'm saying, for popular students, the student will be considered if another student have more than the student's marks.
Yeah.
Like we are
Popularity is,
saying,
More
popular
than
see,
means
at
popularity
least
is
10.
that,
More than
okay,
we don't
at
have
most
upper
20 and
boundary
at least
for
10.
popular students.
Yeah.
okay, can I speak
Basically,
now?
he's saying, yes,
Listen, popularity is based on how many students are mentoring a particular student. Okay, just that. Like in maths, if I see that a student is being mentored by 5 students. In physics, that same student is being mentored by 7 students. In chemistry, that same student is being mentored by 8 students. So total 20 students are mentoring the same student. Okay, so there are 20 incoming edges to that person only. Now,
Yes,
this can
ma'am.
also happen that the same person is mentoring this person in 2 different subjects. Like this
Yes.
C person. He has got 58 in chemistry and he is mentoring A. Now, in physics, let's say A has got 50 and C has got 64. So, C can also mentor A in physics. So, the same person can also be mentoring him across different subjects, but those are duplicate edges. Those you won't count. Okay.
Yes,
So,
ma'am.
from a
But
single
the
person to a single person is one edge.
upper limit should not be there for popular students.
ma'am, I
This
think
is
it
not
would be
for
better.
popularity, na? This is what? This is for finding that who is
Mentoring or
mentoring
not.
whom. Yeah.
Okay.
This is that
Oh,
thing, that
now I
difference.
get it.
Okay.
Okay.
The first criteria is
Yeah.
that
First
person should
criteria is that it
mentor.
has to be marks difference has to be at least 10 and at most 20. This is the criteria. So this is
Yes,
to
ma'am.
find who is mentoring who. Now, popularity is an empty dictionary for each I in keys of math marks. What are the keys of math marks? Sequence number of students. Correct? So popularity I is 0. Okay. So this is sequence number, let's say.
Initializing.
Yeah. So let's say I have sequence number 0 initially, right? So I is 0. So popularity of 0 is 0 initially. This is just initializing. For each J in keys of math marks. So again, I'm going through all the students in math marks. If I see that in math mentor graph, J comma I, that is J is mentoring I. Okay. J is mentoring I. Remember, first one is the mentor, second one is the mentee. So if J is mentoring I, then there will be an edge. That means in math mentor graph, the value in that cell will be 1. If this is true, then popularity I, which was initially put as 0, is now incremented by 1. So every time I find one such pairing, one such edge between I and J, I'm going to increment the value. And this is going to happen across all 3 subjects. So first I'm going to check for maths, then I'm going to check the same IJ pair for physics. That is, if that same person is again, okay, here they're taking duplicates also. So even if the same person is mentoring, like if C is mentoring A in all 3 subjects, maths, physics, chemistry, then the popularity of A is going to be incremented by 3, right? 1 for math, 1 for physics, 1 for chemistry.
Yes, ma'am.
So, ma'am, here the value corresponding to the key I is the number of mentor.
Number of incoming edges.
Okay.
Okay, that means number of mentors across subjects.
I mean, this
And here
popularity will
also
get
the
calculated for all the students, right?
all the students, yes. So that
Okay, ma'am.
we are going through all the students in this outer loop. And for each student, we are again going through all the mentors or all the other students in this loop.
Yes, ma'am.
Yes,
Ma'am,
Okay. So for every I and J, we are going to check for these 3 conditions. Every IJ pair.
ma'am, if
Yeah.
chemistry is not true, is not 1, then it will 0 or 1.
So if I is 0, okay, and for J1, I found that J is mentoring, that is 1 is mentoring 0 in math and 1 is mentoring 0 in physics, but not in chemistry. Then popularity
not
of 0
update.
is going to be 2.
Two.
Here it is incrementing 1, here it is incrementing 1. But for
Yes,
this
ma'am.
one, it won't update. So at this point, popularity of 0 is 2,
Yes.
right? Now again, the j value will change. Now let's say j is 2. And I have seen that 2 is mentoring 0 in chemistry and no other subject. So only increment here, not here, not here. So now the popularity is 3. Understood?
ma'am.
Like this, it will go on for every other student. It will check. Clear?
Yes,
How
Got
ma'am.
this
it,
is
ma'am.
working? And
Thank you.
every time you are done for, let's say for student 0, I've checked all 30 students. Then you are again going to go back to this outer for each and pick the next student, student 1, and again repeat the same procedure. So like
In the
this,
first,
after this, yeah.
sorry, in the first iteration, since you initiated I is equal to 0, right? And when you checked even the mathematics ji, shouldn't it be 0, 0? It will not true, or it may be.
No. I actually did it for 0, 1. Okay, so for the same student, it will always be 0. If you're
Correct,
checking for
right?
0, 0, 1, 1.
Yeah,
So
okay.
I checked for 0, 1, 0, 2, like this.
First iteration will be 0, 0, and it will not
Yeah,
be.
first iteration will be 0, 0. Then again, after the number 30 iteration, when you go to
Correct.
31st iteration.
Correct.
Okay, then I is now 1 and j is starting from 0. But 32nd iteration, I and j are again both 1. So for that
Yes.
also, none of these will work.
Okay, got it.
So principal diagonal elements always remain 0. Correct. Now,
Yes.
principal diagonal elements means what? 1, 1, 2, 2. Okay, all these similar pairs. These are all principal diagonal. Okay, so if I say in an n cross n matrix, how many principal diagonal elements are there?
N.
N.
N number of, right? Okay, n number of principal diagonal. So popularity, how it is being calculated, clear everyone?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay, see. Now they're saying avoid duplicates. So explicitly keep track of mentors for each student and count them. Okay, so how is this working? See. First, I have a mentors table, mentors dictionary, a popularity dictionary. Okay. Now for each j in columns of math mentor graph, I'm starting with columns. Okay. So this is the reverse order. Now I'm starting with columns. For each column, okay, I have created a nested dictionary in mentors. So what are the keys of mentors? Outer keys are the column indices.
J. Yeah.
Correct? All the j values. And for each j value, there is again another dictionary which is consisting of all the row indices for that column. And corresponding value is the value in that cell of that column and row intersection, right?
Yeah.
So
You
for
will
each j or each column index, I have an empty dictionary. Now for each I in rows of math mentor graph, if math mentor graph ij is 1, that means I is mentoring j. Okay. So initially I is 0, j is 0, I is 0. Then for j 0 only, I is incremented to 1 because we know for 0, 0, there are no edges that are 1, right? So for 0, 1, let's say, I'm going to check if 1 is mentoring 0. If true, then this is going to be equal to 1. In that cell, I will find the value 1 in math mentor graph. If this is true, then mentors ji will be assigned the value true. In mentors matrix. Okay, nested dictionary is nothing but a matrix, right? So in mentors matrix, ji value will be stored as true. That is 1, 0 means 1th, or I can say the like number 1 index row and 0th index column. That value is going to be true. Okay, this one always represents row, this one always represents column. Clear?
Yeah.
So for ji10, this is row with index 1, column with index 0. And if
Ma'am,
they are,
Ma'am,
yeah,
here,
together they represent element of matrix, huh?
yes, correct.
ma'am, here mentors ji. That j represents column or like because that for loop we're considering j in the columns.
See, here I'm checking who is mentoring who. Okay, so here I is mentoring j, that's why it is a 1 here. if this is the case, if I is mentoring J, then in the actual mentors matrix that we created here, okay, a nested dictionary, this is, in this I am going to put Ji value as true.
Okay,
Why
okay, got
Ji
it.
value is true? Because for J, I am seeing the popularity, na? That J and I, that is J is getting mentored by I. Yes, then it is true.
Yes, ma'am.
Ma'am,
Okay.
Okay, got it, ma'am.
but in that where it is written mentors JI, shouldn't it be 0, 1? Because J is the column, right? For each J in columns.
Yes, correct. You're right. This is 0, this is 1. Sorry, I missed that. So this is 0, 1, right? The student 0 is getting mentored by student 1. So this is true. Okay. Now,
in initial, the initial part of the code, it says mentor dictionary as empty dictionary, right? And then after that, we are calling mentors J as a dictionary, as 0 dictionary, as empty
right,
dictionary.
right.
So difference between mentors and mentors J dictionary, that means in the mentors J should be always the first element or first key value. What is the difference between these two? In terms of the way
See.
they are represented with J and with nothing.
Yeah, see. So mentors is what? Empty dictionary. When I say for each J in columns of math mentor graph. Okay. So this is actually every index of column. So for every column index, I am now creating a dictionary for the rows. Okay. So mentors J. If J is 0, that means this is actually representing the column 0 and what are the row values in that column.
Okay, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6. Okay,
correct.
got it.
Okay. So similarly, you're going to check for physics and chemistry. So this is actually basically the same procedure that we are doing previously.
So,
But
ma'am,
here you say,
ma'am, just I have one doubt. So this mentors dictionary, like mentors matrix, will have one column that is 0, and the value like for different rows, like column is
for
0
different
and
rows.
1, 2, 3. We will get a column that will be
Correct.
true, filled by true, something like this.
Correct. Yes.
Okay.
But whenever you are writing as IJ format, always remember the first one is the row, the second one is the column. Okay. This format is same. No matter what I and J represent, this format is always going to represent row and column. Okay.
Means I represent row and J represent column.
Like the first one that you put here, right after the name, this is the row one. And this is the column one. Okay, let me just erase this part.
Okay, ma'am. I got it, because I think now there is a other matrix mentors. Now that J act as a row in that new mentors.
Yes, that's what I was trying to tell you. That
Okay. That
even though we
J.
are taking J as the column index, here when we put it in mentors matrix, then J becomes the row.
Okay. That J is column in that math mentor graph, but here in mentors.
Right. But in mentors matrix, it is J is the row.
Okay, got it. Thank you.
Can we also see like this way, like mentors of J will be the outer dictionary and I will be the inner dictionary.
You can do the reverse order also, just have to maintain it properly. Okay.
Just for reading, I mean, for understanding purpose. So here, I will be the inner dictionary, J will be the outer dictionary.
If you are taking, can you just tell me from the beginning what you want to do?
No, just to understand mentors of J of I.
Okay, mentors of J, right?
Instead of
So
row and
if I
column.
say mentors Ji is true, okay, if I say mentors Ji is true, it means J is mentored by I. Okay. So that element will be true. That Ji cell will be true if I is mentoring J. Where am I checking that? That is being checked in the if condition. See. Here, what does it represents? Math mentor graph ij is equal to 1 means I mentors j. That's why it is having a value 1, that cell. Once this is done, then in the mentors matrix that I created, here I will store in ji format. Okay. So the row
Now
is
here-
for j and the column is I.
Now here J is a row.
Yes, here j is row. Here.
Which is the outer dictionary, correct?
Outer dictionary, no, it's not like that. See, these are two separate dictionaries. One is math mentor graph, one is mentors. These are two separate matrices. Okay.
Ma'am, I guess it would be better if you explain using making a matrix.
Yeah, please take an example
It will be easy.
Example, let me see.
with few
No, not
elements.
ma'am example. Just if you make a dictionary with 1, 2, 3, 1, 2, 3 rows and columns, then explain this. It would be easy.
Okay, so if this is your math mentor graph.
Yeah.
Okay, so I have say only 3 students, 0, 1, 2, 0, 1, 2. Okay, so here I am saying that 0 is mentoring 1. So here I have a 1. 0 is not mentoring anyone else. 1 is mentoring 2, not anyone else. 2 is mentoring 0. Clear? Now,
Yes, ma'am.
in the mentors table, how I'm going to fill this up? See, here also the same thing, 0, 1, 2, 0, 1, 2. Sequence number are the keys. Now, what am I checking? For each j in columns, that means start from 0 here. Okay, in math mentor graph. So mentors j is now what? An empty dictionary. So mentors 0. Okay. So when I say mentors j, I mean this one here, this row. Okay. This is the thing I think you're getting confused in, that I am picking from columns, but I'm assigning it to row in mentors, right? But the
Yes.
sequence number is same, na? That's why it's not a problem.
Yes,
Okay.
ma'am.
So I am picking j is 0. Now in mentors matrix, I have created a dictionary for row 0, let's say. Now I'm checking for each I in rows of math mentor graph. So for what is the first I? 0 here. Okay. So we know that for similar ones, there will be no mentor present, right? So let's go to the next one, which is 1. So now I'm checking ij value is 1 or not. So what is ij value? 1,
0.
0. 1 is I, j is 0. So is there is 1 mentoring 0?
No, ma'am.
No. Okay.
Can I
So
ask
what I will do? Yeah.
Can I ask a doubt?
Yeah, sure.
Math mentor graph is a square matrix.
Yes.
Why is the different? Well, there is no difference between column and row. All we
No,
need.
no, there is no difference.
All the
You
students.
can pick any.
You got to compare each student with the rest of the students.
Exactly. So you can pick any. You can pick from the rows, you can pick from the columns, doesn't matter.
So the third line could have been row, fifth line could have been column.
Yeah.
Maybe because of
Same thing you could have done.
because we changed that numbers and things like that, we are getting confused.
Why we are doing this is because actually, since we are more comfortable in row column notation. Okay. So that it comes in mentors table, it comes in row column this way. That's why we are taking J in the beginning. So J is representing row and mentors. Let me finish this example. See, now J is what? J was initially 0. So for J, I am incrementing I, right? So I am checking that whether I is mentoring J. So 0 is not mentoring 1, 0 is not mentoring
0.
0 is not mentoring 0. These are J values, these are I values. Okay.
Who is mentoring
So
2,
for
ma'am?
no, what is it is representing? 2 is mentoring 0.
Oh,
That
yeah,
is
yeah.
why
2 is
here this is 1. Okay. If 0 was mentoring 2, then this one will be 1. So 2 is, so
Yes,
0 is
ma'am.
basically not mentoring anyone in this column, in these rows. Okay. Now for 1, for J value 1, I will check. So for J value 1 and I value 0. Okay. Is
It
I
is mentoring.
mentoring J? Yes, there is a 1. So I value 0, J value 1, I have found a match. Now in mentors table, what is the first index they have said? That if this condition is true, then mentors Ji will be true. So Ji means 1, 0. So pick 1 from here and 0 from here. This part will be true.
True.
This value. Understood?
Yes, ma'am.
Yes,
Got
Similarly,
it.
you are going to check for physics. Similarly, you are going to check for maths. Every time you
Ma'am,
find a mentor, you are going to put it here. But there will be no duplicates. Why? Because if the same person is going to mentor let's say the same J is mentoring the same I or the same I is mentoring the same J in all three subjects, there can only be one edge between I and J, na? So duplicates will be removed. So even if I, let's say 0 is mentoring J1 in all maths, physics and chemistry in the mentor's graph, this one in the mentor's graph, can there be more than one edge between 1 and 0?
No, ma'am, it
No,
will
ma'am.
always be
Only one
one
value.
true.
So
Yes.
we
So
will
that is
take
why,
only one value. No?
exactly, even if all three
It
conditions are
will
true,
be set to true only.
yes, it will be set to true only. So that is how we are avoiding duplicates. Understood?
That's what I was going to ask, ma'am. Thanks for it, ma'am.
Okay.
Well,
Okay. Clear, right? Now, after this is done, then popularity of J, for any J, if I want to check the popularity, what is that? Length of keys of mentors of J. Okay.
yes, ma'am.
That
So we will
means,
get total number of mentors of that
exactly.
element.
So how many keys are there? So here we formed that nested dictionary, right? So for each J value, there will be a dictionary, and whatever are the number of keys there, that is the popularity of J. Clear?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. So similar students, next concept. Similar students are who? Students who have, two students are similar if they have similar marks in all subjects. That is, difference is within 10 marks. So let's say A and B are two similar students. Okay. In maths, physics, chemistry, let's say A has scored 18 maths, B has scored 17 maths. In physics, A has scored, let's say 60. B has scored 65. In chemistry, A has scored 92, B has scored 96. So A and B, I can call them similar because in every subject, you see the difference is not more than 10, right? So A and B are similar. Dictionaries with marks in each subjects I need. First, now I am going to implement this, how to find similar students.
But
I
ma'am,
think this is
condition
the
is
last one.
within 10 marks.
Yeah,
Not
condition is that for each subject, the difference must be within 10 marks.
yes, ma'am, not including the endpoint.
No, that 21 is not mentioned here. Okay, just the 10 marks criteria.
Yeah. Yeah. Okay.
Okay, so first again, I create these read marks, these dictionaries for every individual subject, maths, physics, chemistry. Now we want to create a similarity graph. Similarity graph is what? That two students will have an edge between them if they are similar, right? If they have similar marks. So what is the procedure? Create similarity graph is the procedure name. What are the arguments I'm taking? Marks 1, marks 2, marks
Physics.
3.
Yes, ma'am.
Okay. These are the 3 marks I'm taking for some student. Now, N is what? Length of keys of marks 1. 1 second. I think this marks 1, marks 2 are subject-wise marks dictionaries.
Yes.
Yeah. So this is dictionary for math. This is dictionary for physics. This is dictionary for chemistry.
Chemistry. Yes.
N is having what? Length of keys of marks 1. So for maths, I am finding how many students are there. That is the length. So for obviously there are going to be 30 students from your data set. So N is 30. Now similarity graph is what? Here is where we are calling the procedure create matrix N cross N. That is again that square matrix for all the students I'm creating and calling it similarity graph. This is the graph I'm going to be updating. So whenever I find two similar students in this graph, I'm going to put an edge or change the cell value to 1 for that particular IJ value. Okay. So for each, 1 second. Yeah. So for each I in keys of marks 1 and each J in keys of marks 1. So basically comparing every student with every other student. If the difference, IJ difference 1. So this is for maths marks difference. Okay. And we are going to take the absolute value. So even if it comes in negative, we'll just take the mod value of that. Okay. We don't know which student has scored less. So first I'm finding the difference of student I with student J in mathematics. Okay. And storing that difference in IJ difference 1. Similarly for physics, I'm storing in here, and for chemistry, I'm storing in here. After these differences are stored, now I'm going to apply the if condition. If difference of maths marks is less than equal to 10, that is within 10. Similarly for physics and chemistry, so it is all joined by and conditions. Similar only when all 3 subject differences are within 10, right? That's why and condition. So if this is fulfilled for students I and J, then in similarity graph IJ, I'm going to put the value 1. Okay. So similarity graph, you might have this question, why not in JI? Right.
Because
So
ma'am,
that
we
is
are
also
already
the
taking absolute, no?
right. So we are already taking absolute, so it is the same thing. You can put in any of them. Okay. Now, this is how you are going to do the similarity graph. So for every student, you just have to check the difference, whether the difference is within 0 to 10. If it is greater, then no. Even if in one subject, if the marks difference is greater than 10, then you cannot call them similar.
We
Procedure
just,
clear?
ma'am, the matrix will be initialized as 0, right? The elements will be 0, right?
Yeah, the similarity graph will first be, when you're creating it, all the elements will be 0. Then as we keep on checking for each ij value, then I will update them if I find similarity.
Okay, ma'am.
I will update
Means
them to 1.
the matrix is just similar to the previous matrices, what we have prepared for that read marks, right?
Yes, exactly. Same thing. Just here, the condition
Just
is
the
different.
conditions are different. Yes, ma'am.
Correct. Yeah.
Ma'am,
Other questions?
so similarity, ma'am, so similarity graph principal axis will be always be 1.
If I find two people who are similar to each other, then for that ij value in the similarity graph, ij, that element I'm going to put the value as
Ma'am,
1.
similarity graph is a matrix.
Yeah, it is a matrix. Every graph I am representing as a matrix.
So ma'am, its principal axis will have only value 1 only.
Principal axis will have only value 0, right? Or principal
Ma'am, why?
diagonal, or
Because the
which one are you
difference
saying?
conditions are less than or equal to 0. It's also considering 0 also.
And that will be right.
See, principal diagonal I can tell you will be 0 definitely for similarity graph. Okay, these diagonal elements are going to be 0 because their difference, I'm sorry, they are going to be 1. Yes, you are correct. I'm sorry. This is going to be 1. Why? Because all the differences are going to be 0. So this is always less than equal to 10.
Yes,
This is
ma'am.
what you're asking, right?
Yes, ma'am. Yes, ma'am.
Yeah, principal elements will be 0. So for will be 1. So this is interesting actually, because till now we were saying that all the principal diagonal elements were always 0.
Yes,
So now it is 1.
Yes.
Right. Because
But
a student is obviously similar to himself.
madam, that will be incorrect, no? I mean, you're comparing with self.
No, see,
No.
you will compare, no? Because when I is 0, J will always start from 0. So 0 comparison will also happen.
Yeah, it will happen, but the result.
Result is what? See, marks is same for maths.
But it
So
would be two different students. You are comparing self with self. So
two
that
different students I want to compare, but when I'm running these loops, nested loops, it is going to compare every student with itself also. Since both are coming from keys of marks, na? So keys are same. So both are going to get, every student is going to compare it with himself also, along with other students.
So isn't that
That's
condition
why
should be 0 to 10? Why 0? Should not be less than
yeah, so the condition is what? The difference of marks should be 0 to 10. So for the same student, if you compare a student with himself, all his marks differences are going to come as 0
No,
here,
what I'm saying
right?
is, yeah, why less than or equal to 0? What I mean by that, I mean, it's left side, it is open-ended, right? Less than or equal to 10, right? It is open-ended on the left side.
It
So
is
I can't-
open-ended on the left side, but you cannot have a marks that is less than 0 because I am taking absolute value.
No, correct. So I was
Right.
thinking if it's better to put, instead of getting this diagonal value as 1, 1, 1, isn't it good to put a condition, let's say less than or equal to 1? Because
You can, definitely you can do that. But if you do less than or equal to 1, you're saying that the marks difference should be less than or equal to 1, right? So what if there are two students, okay, A and B, who have scored same in maths, but different in physics and chemistry? Okay, 70, 80, and let's say 90, 100. So they are also similar. But this condition, if you put like 1 as the limit, lower limit, then it will give a wrong answer for the first one. Na? And even if one of the differences is wrong, then what will happen? The entire thing will be wrong. They will not be compared as similar students.
maybe we shouldn't compare when I is equal to j.
If you want to leave out the self comparisons, okay, then we have to insert some other condition so that for this I value, the corresponding j value like equal, when I and j are equal, for that the comparison won't happen.
Correct, because we are comparing two students, right? Showing one
But
for
it is
similar.
possible two students can
Ma'am,
have same marks in
so
one
we can
subject.
say this is a side effect
Definitely.
we are getting. Ma'am,
See,
so we can say this is the side effect we are getting of comparison itself from itself.
yeah, sure. But actually, this is not, there is no harm in this. Even if this comes, there is no harm in it because we all know that a student is going to be similar to itself. So in a similarity graph, it actually makes sense if the principal diagonal elements are 1.
Yes, ma'am.
Okay.
It will be a unit matrix.
It is like your reflexive relations. Okay.
Yes, ma'am.
The same thing is applied here. If you want to avoid them, sure you can. So every time you find an I equals to j, you can assign a 0 at that point. Okay. So before you do any of this, just put a condition here that if I equal to j, then this similarity graph
Exactly.
ij, you put it as 0.
Got it.
Okay. This you can do.
Got it.
So what is the summary? That graphs are a useful way to represent relationships and edge from I to j if I is related to j, like if I is a mentor of j. Again, an edge will be represented in the form of 1 if there is an edge present. If it is 0, that means no edge from I to j. Right? So any question throughout the
Yes,
theory
ma'am,
that we
I have
did?
a question.
Yeah, which one?
Ma'am, in the popular students one.
Okay. Popular students, this one. This one
Yeah,
or this one?
I just wanted to know why we needed another pseudocode rather than the first one.
Wait, another pseudocode rather than the first one. That is, this pseudocode is fine with you, but why did we take this one?
Yeah.
This is to avoid the duplicates. Okay. Duplicates means what? That if the same student, say this student J, whatever his index is mentoring this student I throughout all the subjects. That is, he has scored within that criteria in all 3 subjects. That is greater than 10, less than 20. Then I in maths, physics, as well as chemistry. So he can mentor I in all 3. But we don't want every time I find this IJ mentorship relationship, I don't want to increment the value that we were doing here. Every time I found one relationship in whichever subject, I am incrementing by 1. So this can create duplicates now.
And we can simply put that first if statement, make it as a second time else.
The main difference here is that
wait a
for
minute.
J,
Inside the loop, first you are checking if math mentorship is not there, else physics mentorship, else chemistry mentorship. So it gets
definitely. See, all of these things are your logic. You can put it into pseudocode any way you want. What I am trying to explain to her is that the difference between these 2 codes is that here the duplicates are being counted, because even if J value, even if this J is mentoring this I across all 3 subjects, then how many times will it get incremented? The popularity 1,
3
2,
times.
3. But
So,
here,
Mama got it. Understood.
yeah, that's why we are using true. Okay, not
Yes,
using any
ma'am.
values.
Yeah, understood. Thank you.
Yeah.
Not
Anything
considering
else?
cliques and other things. We are not covering those topics.
Yeah. I will tell you. I'm just asking till now. You have any doubts?
No. Thank
So
you.
that cliques part, I actually do not have the slides for that. So I was thinking of doing the activity questions that is covering everything. Okay.
Yes, ma'am. Yes,
Clique is nothing. Wait,
Okay, ma'am.
since you brought it up, let me just tell you what is a clique. So say these are 3 students. Okay. If they are all connected to each other, then this is a clique. Okay. Just this simple thing.
Yeah.
That is, if there is a subgraph of a bigger graph. So we have exactly 30 students are there. So this is a big graph. If I take any 3 students A, B, C from there, and they are interconnected, that is every node in that clique is adjacent to each other. Adjacent means only they're interconnected, right? A is adjacent to B because there is an edge from A to B. So if all the nodes in a subgraph are interconnected, then that subgraph is called a clique. Simple.
There is no criteria for directions, ma'am.
Directions, I'm actually telling click in. Okay, if you want direction, you can give.
Ma'am, I'm just asking that
This is
is there
actually
any
better.
criteria for directions? Like if we take
No, see, it is
opposite.
better to think of this as an undirected graph. Why? Because undirected means here A is adjacent to B, that is A to B, there is some relation, again B to A, there is some relation. It can also be directed, that is also
It can
fine.
have any directions. That's
It
what
can
I'm
have any
asking.
direction. This direction can have.
Minimum is
Basically,
3
they
nodes
just have to be
required.
connected.
Do we
Yes,
require
ma'am.
3 nodes minimum, or even the 2 nodes are connected? That is a clique.
2 nodes is also fine. At least you should have 2 nodes.
Okay.
Okay. So when you
got
have
it.
two nodes, then it can form a clique. Okay, let's do
Main
the activity
fundamental is
questions.
interconnection.
Yeah, fundamental thing is that all nodes should be adjacent to each other.
Oh, thanks, ma'am.
Okay, 1 second. Let me find the activity questions. You are fine with it, right? It's a little over 8. Can I continue or do you want to do this in next class?
If you want to continue, ma'am, you can.
I have
Ma'am,
no
next
problem.
class,
If you
ma'am, there
people
will
want
be
to.
a status.
As you wish, ma'am.
Okay, you have
I will
another
give you
class.
some of the
Primary
questions.
statics class will not.
Few
You are sure?
activities
See,
we did.
see here. Is my screen visible?
Yes,
No,
ma'am.
ma'am.
No, ma'am.
No,
Not
ma'am.
No, ma'am.
1 sec. Now?
Yes,
Yeah.
ma'am.
Yes, ma'am.
Okay, look. Here, this is week 9, right? So we have done up till this lecture, activity 6. Okay. So up to activity 6, very basic questions. You try yourself. If not, anyways, it will be discussed in tomorrow's lecture. So tomorrow I will ask Piyush sir to cover lecture 7, which is basically again the same graph representation, just using a different data set, that is trained data set. Okay, using this trained data set, you will do the graph representation and the practice assignment is left. Okay, so tomorrow just this lecture 7, activity and practice. Fine with everyone, right?
Yeah.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
So, ma'am, you
Thank you
will
so
not
much.
discuss this practice session, like practice assignment.
Piyush sir will discuss tomorrow's session.
Okay.
Okay.
Thank you, ma'am.
Yeah. Thank you so much. Have a good night.
Thank you, ma'am.
Okay.
Have a good night.
Thank you, ma'am.
Thank you.
Thank you, ma'am. Good
Good
night,
day,
ma'am.
ma'am.
Yeah. Good night.
Good night, ma'am.
Good night.
Thank you.